Good afternoon, everybody. How is OCP going for everybody? Good, great, good. So we'll be talking about today how to build, secure, and scale and deliver open source firmware, especially the platform firmware. My name is Sanjoy Maity, CEO of AMI. Many of you know AMI very well. What we do, we make dynamic firmware for the platform, which is foundational firmware. So we also have other products. Our main goal from AMI is to help ecosystem in scalability, sustainability, and security, and which is built around the community. So we take the open source and we build solutions. And from the AMI side, we have solutions like dynamic firmware, which is the platform firmware, which is BIOS, BMC, and security firmware. On top of that, we have other sustainability product, which is data center manager for doing the power usage efficiency, then carbon footprint calculation, forecasting, those kind of things. That's all that's AMI is. Today, I'll be talking about open source based dynamic firmware, how the industry trend is, and what we see and what we are bringing to the community. So we'll be touching 4 things today. One is the current landscape of the platform firmware. Then we'll talk about some challenges, some problem statement that we are seeing around the open source firmware. And third, I will be talking about a possible solution. And then number 4 is our commitment and our contribution to OCP and the community. Saying that, what I will be covering today, there are many platform firmware, and there could be, we counted one time, a laptop even have 22, 23 small firmware. So we will be talking about 3 major firmware today, which is the boot firmware. We know we love BIOS for many, many years. AMI is a key provider of BIOS in this ecosystem. Second is a manageability firmware, which is the BMC firmware. And third one is the security firmware, which is a platform root of trust firmware. We'll be talking about 3 firmware that coming from AMI, how it is built around the community using open source, and what is our contribution over there. So what are the ecosystem challenges that we see today? You probably will agree or maybe disagree. So what we see is the scalability part. So there are 4 things when we are building a platform, the foundational platform. How do we build, how do we scale, how do we secure, and how do we deliver? All 4 are very important today. So in the ecosystem, when we are using open source or open architecture components, the first thing comes into the picture is the interoperability. So when we are talking about scalability in this ecosystem, of course, there are so many different vendors, and we, being a Switzerland in the ecosystem and helping the ecosystem, we would like to see the maximum scalability and the interoperability among all these vendors. So first is the BMC, that we know there are multiple BMC vendor or provider, from Speed, Novoton, Axiado has an exciting solution, and there are future BMCs are also coming. Second thing is the platform root of trust. There are also multiple silicon that we see, depending on the platform, depending on your need. There are scalable silicons. It goes very small silicon to a large FPGAs where we can do a lot more on the platform security side. And how do you have the root of trust interoperability among all the silicons? These are the challenges the ecosystem providers, all these system manufacturers, ODMs, they face every single day. Third one, I would say the resiliency is a very important thing. within AMI, we believe that the system design and the software development with firmware development becoming more and more complex. That means how it is developed securely and how resilient this whole system is. It's very important. So it comes into how do we maintain the protect, detect and recover part of the firmware, and also other component like memory resiliency, non-volatile RAM resiliency, and so on and so forth. Fourth one is the end-to-end attestation. We do something in the platform level. How do we bring that information to the upper level with a remote attestation and end-to-end attestation of the platform? And finally, last not the least is the end-to-end manageability. And we need to manage the entire fleet or data center or a large deployment. How do we do that? And first thing comes in our mind is the sustainability. We are growing, there are complex architecture. How do we maintain the sustainability of our design? So we need to make sure that we have the intelligence in our firmware, manageability firmware, where we can put the power utilization efficiency, telemetries, all sorts of things. So those are very important, and these are the challenges in the ecosystem that we see today. So when we talk about the open source, and we are doing that for several years now at AMI, we are the prime contributor in OCP for the platform firmware today. The main challenges that I see is the scalability. How do we scale the firmware development? Then the security. How do we secure the development and the firmware? Third is the interoperability, as I talked about, and the resiliency part of it, and accountability. There is a large supply chain today, and this firmware is touched in many places, many parts of the world, many different ODM, OEM, and the core independent firmware vendor. How a software bill of material is generated, how it is maintained, how it is checked, how it is attested. So these are the main challenges that we see. Sorry about that. So first challenge we face is the open source is very good for several things: innovation, transparency, and freedom. You keep on innovating, you use it in-house, and there is no restrictions. It's very good, but at the same time, the open source is fragmented too much. So that means we see in the industry varieties of solutions coming from different vendors or different manufacturers. There are large companies who can maintain a proprietary code based on an open source, and they're capable sometimes. Very few companies, they are really capable of maintaining and managing this code base in-house. But for an ecosystem where we support the ecosystem, especially from the ODM point of view, system manufacturer point of view, it is a challenge. It's a bit of challenge. So sorry for this is a busy slide, but I would like to show with colors that what are the different fragmentation can happen. If you think of this way, let's say I have 5 teams. I am a system manufacturer, I have 5 teams. One team is doing one silicon vendor, Intel's Sapphire Rapid. Another team is doing Intel's Granite Rapids. Another team is doing AMD development. From each vendor, there is a separate tree, and there is a different OpenBMC version. There is a different kernel. There is a different support for U-boot. So at one point, I see that individual team is handling different repositories from different locations, different links. So that makes the managing the firmware development extremely complex. And not only that, sometimes each individual team will deliver the product on a different kernel, from the same company, on a different OpenBMC version, on a different tree completely. So when we put together this on a modular system, it gets even amplified. How it is? Because now in the future, we know that there will be cross-vendor HPM will come, and it will be swapped within a modular system. And think of previous page, we have seen that each silicon vendor is maintaining a different code bases for their individual different silicon generations support code. Now it is getting amplified. So within a data center where this is a heterogeneous environment, you will end up having so many varieties, combination of modules. So if you think of the SBOM complexities, it will be tremendous amount of complexities within a data center. Same goes with the BMC side, because your DC-SCM module can be swapped at any time, right, from cross vendor. So we recognize this problem, and it's not just the BMC side. We will be seeing some example today, but in the system firmware side, if it is open source based, especially for the boot firmware, the BIOS side, we believe there is a restructuring or a way of maintaining the open source is required just for the scalability purposes. There are so many different type of applications, so many different type of deployment. We see a lot of open source items today. It could be, we know these names, Tiano Core, ETK2, Slim Boot, Core Boot, Linux Boot. We all familiar with all the open source things, but when it comes into the picture, it is complicated how to maintain a singular version of a truth, that one version of source code which is maintained and it can be used by the industry, by the community. So today AMI had contributed to OCP. So we took all these things, we created an architecture, and we take Tiano Core and we take UFI together, and that is the version and Intel FSP, and that is the version we contributed to OCP as a singular version of truth. We have added also AMD OpenCell support. We are waiting from AMD for a final approval, and we will be able to contribute that on a single version of code base, and that is contributed to OCP. OCP accepted open source. So this is the difference between the individual open source item versus what OCP does. Okay. Second thing, I will talk about the BMC side. If you think of the BMC complexity, there are multiple BMC vendors, which is Speed, Nuvoton, Axiado, and there will be future BMC vendors. We know that. And there are different silicon vendor on the left hand side. So whenever you see the combination that multiple BMC vendor solution on a multiple silicon providers, multiple generations, we have to deal with a combination of silicon generation, OpenBMC version, kernel version, public repo, and the private repo. And that yields a massive combination where we should pick and start a project. We combine everything, we restructure, and we maintain it from AMI side, and we contribute it to OCP. And that is available in OCP today, where you can start a project with any of the silicon vendor with major two BMC vendor, Speed and Nuvoton today. Axiado will be there maybe in next 3 to 6 months, the support. Then you can start a project with a single version of truth. That's the OCP version as opposed to, and Linux Foundation is still, it's the same version of the software we take and maintain in a cadence after going through the testing and restructuring such a way that the community can use it. Linux Foundation is mostly for the innovation, transparency, and freedom. And our commitment is to use that and package it such a way that we can contribute to OCP and the entire community is benefited from that. So there is a lot of effort goes behind that. This is a slide, but I will just touch, I will not go in detail. But these are the major activities, and it's a significant activities that you have to continuously do to combine this whole thing and to maintain a single version of truth. One is the upstream, downstream effort. Second one is the feature update and the syncing all the time, repo syncing, and the most difficult one is the kernel versions. Unless we are on one single version of truth, we cannot address all the security issues in the firmware, all the bug fixes in the firmware when you are delivering. So this is the overall challenges that we have seen. So of course, what we did, we basically created something from AMI we call one tree, and the core is open sourced. The bottom portion, which is exactly like Linux Foundation, not like, it is from Linux Foundation. We contribute to Linux Foundation independently, but the right hand side OCP version is something that you can take and you can build a product and you can deliver it. That's the difference, and that is actually the main message and the solution for this fragmentation that we are seeing. On top of that, you can have all different kind of add-ons or expansion pack, we say, or technology pack, which is needed to create a sophisticated manageability on top of it. Those are the IPs that our customer can develop and we also provide. All put together, we have a solution called One Tree. We are demonstrating that in our booth, and so this is the most scalable format development for the open source. And little bit about how we address it, right? How did we do that? Of course, by collaborating, right? We collaborated with silicon providers and created this entire thing together because there are different versions of truth in the open source. So let's see how it happens, right? The first of all, there is an OpenBMC code from the Linux Foundation, and then all silicon vendor, when we work with all the silicon vendor on the right hand side, we know that they are maintaining their silicon generation specific code bases, which we call, their own private repo, and over there. We combine everything together, and that is the thing that we have contributed to OCP. So this is the difference between the OCP version. Why OCP version is a production worthy, and it's a product for delivering a final solution. And this is open source completely, and this has the same core features. Also, on top of that, we have OCP contributed platforms recipes, and it's a single branch. It's not multiple branch. Here, if you see on the right hand side, under Linux Foundation, if you have to take care of the different branches, there are multiple branches over there. And all silicon provider support will be in one branch. That's the goal. So it's still an open source. Anybody can download it. Anybody can do a project. But AMI can also support if needed. Now what we did, we are also working with the silicon vendors continuously, and we are bringing the next generation silicon support, extra features, silicons providers specific features, all the advanced technologies, and we build this one tree. So overall it looks, this is the process, this is the overall theme, but when we put together, it sounds simple, but when we create the firmware or develop the firmware, it's not that easy. It's a bit complicated. So what we did, we have built something called Build Orchestrator, and this is a service. This is a platform, SaaS platform of developing firmware that we have created at AMI, and that will hide all the complexities. So if you see, we have Aptio, MegaRack, and Tectagon, 3 product line that we have, which is our boot firmware, BIOS, second is our BMC firmware, MegaRack, and third one is the security firmware, Tectagon. All are based on the open source, and they are open sourced already today. The Build Orchestrator takes the complexities of all the combinations and create a scalable firmware, scalable in terms of target build from enterprise level server to a hyperscale server's need to even a small IoT and embedded devices. So that's the scalability part of the firmware building. We encourage and we tell everybody that please come and join this community of open firmware, and we can build a better firmware, structured firmware, within OCP, which can be used for the entire ecosystem. So far, AMI has contributed to OCP all 3 firmware, both BMC and security. We have contributed independently many things to Linux Foundation directly. And you know the difference by this time that is for more of an innovation, creating transparency in the industry and everything. When you take that and create a buildable product and sellable product and deliverable product, that's the OCP version. Saying that, I'll say that thank you, and please come to both A33, see us. We have exciting demos there, build orchestrator, one tree, and how we are scaling, as well as the sustainability part that we have on top of the firmware. And I can give 4 minutes back to all of your valuable time, or I'm available for any question. Thank you. Yes.
Yeah. Is this on specific set of platforms? What I mean, specific chipsets associated with different vendors, and then you produce it? Or obviously there cannot be a full open, since everything working on every platform, right? How does it work?
Good question. So what we have done is, when we work with the silicon provider, then we have, of course, there are standard features which can be open sourced to build a BIOS or BMC, right, for that particular platform, if the platform is open to OCP. There are advanced silicon features which we are not allowed to open source, and they are not needed immediately. They are advanced features. So those are not definitely public. And also, if you want to start a project, let's say today, for the future generation with an early access, those are the features will not be open source for many months, because that is the advanced feature. Those will be all closed source for some time. But if it is a platform, for example, let's say, I don't remember the new platform that we have submitted, but Tiago Pass was an example, right? That is an OCP platform that we contributed. You can download and you can build it. Every feature is there. We don't have the sophisticated building tool, that is our product, but there is enough build scripts are there that you can build firmware. Any other question? Okay, thank you, and hope you all enjoy the rest of the show. There are a lot of exciting things in the show. Thank you.